Naveen, you're preparing for what?
What, sir?
What are you preparing for?
Sir, actually, I am selected for ECIL interview, sir, Electronics Corporation of India Limited. On this month, on 29th, I have interview.
Okay.
This month, 29th. So for that, I need a mock interview. Actually, they given 50% importance to the interview, sir. I'm expecting some technical interview from there, from ECIL for that mock interview.
So you're from mechanical background, right?
Yes, sir. I am from mechanical background.
Okay. Okay, Naveen, then let's go ahead with your mock. So first of all, introduce yourself briefly to us.
Yes, sir. Good evening, sir. My name is Nabi. I am from Srikakulam district in Andhra Pradesh. I am graduated from GMR Institute of Technology in 2020. Since 2020, I am preparing for GATE exam. And this year, I got a good rank of 117. And I did my internship in NTPC near to my home for 1 month in my engineering. And my project is on electrolysis coating. My father is a farmer and my mother takes care of my home. That's it, sir. This is about myself.
So Naveen, what are you doing presently?
So right now I'm presently preparing for competitive exam. From last 2 years I'm preparing.
No, that is okay. My point is that you are saying that you have got a very good rank, 117, right?
Yes, sir. This year, 22.
Grade 22, right?
Yes, sir.
So what are you doing after that? Where did you utilize your score?
Sir, still now this is the first opportunity from ECIL I had. Yeah,
So
this is the first opportunity.
what is your like goal? What you want to achieve through GATE? What you want to achieve?
Sir, my primary aim is job, sir. But not only job to earn money, something which gives me happiness while doing. When coming to ECIL, ECIL is in many. It is manufacturing many products and designing many products. I am very much interested in dealing with many problems, many projects to work on many projects. So my primary aim is some technical work, and job is the primary aim.
So job mean any job, you are ready for any job?
No, not any job, some design kind of job.
So what option do you have in design through GATE?
So for time being, I have ECIL and DRDO, BARC. These are the.
Okay, so are you expecting any calls from PSUs?
Sir, right now I have good rank, so definitely I will get calls
Which
from.
which PSU you are targeting?
Sir, there are many PSUs.
Okay, you are having many PSUs. Okay, so given the
Yes.
choice, which PSU would you like to join? You may be having in mind, okay, this is what I want. I want to get into that PSU, right?
Yes, sir.
So which is in your radar? Okay, this is our PSU I want to get into.
Sir, I gathered information about all the PSUs like ECIL, HIL, IOCL, and NTPC. When coming to work nature, many PSUs are only focusing on same works like preparing petrol, diesel, creating power. When coming to my interest, I am interested in working on different projects. So ECIL is in first preference of mine because it is uh, I identified few things in ECIL, that is ECIL is focusing mainly on new technologies where like transforming X-ray report into digitalization, and the first computer is manufactured by ECIL. Like that, ECIL is focusing on new technologies, sir. That is the key point why I'm kept ECIL in my first preference.
So, so what are your favorite subjects, favorite areas?
When coming to my favorite subjects, the strength of materials, heat transfer, thermodynamics are my favorite.
So you also have done a project. What was the project? It was on
Electroless coating, sir.
What is that? Electrolux coating.
Yes, sir.
What is it?
Means without electricity, we will take one base material, sir. On that we will go for coating to improve surface properties like hardness, wear rate, corrosion rate. Those properties are surface properties. No, we
So
are,
how is it done? How is it done?
sir. Actually, we will have some diesel, sir. We will heat diesel, and there is another solution. Yeah, another beaker we will keep inside that oil for uniform heating. We are using that oil. Firstly, we will heat oil. From oil, it will be transferred to the solution. Inside that solution, we will add nano powders, sir. Al2O3 and SiC, silicon carbide. Nano powders we will add into that solution. Now we will keep the specimen into that solution. Now, because of this heating, these nano powders go and will deposit on that specimen, sir. That specimen we will go for some heat treatment so that good bonding takes place inside with the parent material, and then we will then actually we performed a hardness test and we identified which specimen given good result. Actually, we will change the configuration like uh, uh, 1 gram of aluminum oxide SiC, 1 gram of SiC, 2 gram of Al2O3, 2 gram of SiC. Like that, we changed the gram and we identified at what concentration we are getting high hardness. That is what the experiment we did.
So where do you find its application?
Sir, application, sir, right now, a specific application I can't say, but uh, in aerospace and DRDO, this will be helpful, sir.
No. So this process may already be being used somewhere, isn't it? That it is not that you have first time used it, right?
Yes, sir.
So it must be having certain applications. Which,
Right now, not able to recall where it is.
okay. So Naveen, what is this principal stress?
Principal stress, sir. Sir, when we are loading on a object, there will be one plane on which shear stress will be zero, sir. On
What
that
kind of
plane,
loading?
it can be tensile, uniaxial tensile, or compressive loading.
Mm-hmm.
Uh, at, on some plane, the shear stress will be zero. The stress on that plane will be we call as principal stress.
Mm-hmm. Okay, let's say you have one object. I'm giving you, let's say this is a rod, mild steel rod. Okay, so I'm subjecting it to pure torsion.
Pure torsion.
Pure torsion. Okay, so tell me the location of the plane, principal plane.
Sir, I will make use of paper. Sir, and increment. Sir, actually, due to torsion, shear stress will be coming, sir. When I take an element in the object, that object will be under pure shear. That element, if I rotate it by 45 degrees, means at the same place at a 45-degree orientation, if I take a plane on that, I will get equal tension, that magnitude of tension and compression. That plane will be principal plane.
So how we came to know that? How did you come to know that?
So I will draw one more circle. From there, I will identify where there is shear stress here.
Go ahead with the more circle. Let's just bring it in front of camera. Just bring it in front of camera this way. Okay. So tell me where this component, in which plane this component is going to fail.
Sir, it depends on the material. If it is ductile materials are weak in shear. So because of shear, this shear uh, failure will come, sir.
Where? In which plane?
So this is a shaft, and this is the plane on which, if it is a ductile material. If it is a brittle material, then uh, brittle material is weak in tension. So the plane will be like this. So the, uh, second plane, it is inclined plane. There, if it is a brittle, generally we will make with the ductile material.
No, where, in which incline? Incline location of inclined plane at what angle?
45 degrees.
It will fail at 45 degrees.
Yes, sir.
Okay. Flexural rigidity. Do you know the meaning of flexural rigidity?
Structural rigidity. Yes, sir.
What is it?
Mathematically, it is a flexural rigidity means EI. We say EI is the flexural rigidity. If a material having more flexural rigidity means it is resist it. The bending of the beam will be very less for a given moment, for a given loading, sir. If flexural rigidity is low, means for the given system of loading, bending will be more.
And what is section modulus?
So section modulus will be it is a geometric property, and this will be equal to moment of inertia divided by y. I by y we will calculate that.
So what does this tell?
Sir, actually, the strength of the beam, there is a word, sir, strength of the beam, that is equal to material strength multiplied by section modulus. If the beam is having more section modulus, means it can resist more bending moment. It's
So,
we can say that this is a strength, geometrical strength of the beam for bending.
So then how the flexibility and the section modulus are different? They are giving the same meaning.
Yes. Sir, EI will EI will be like some stiffness, sir. And for the loading, how much deflection we are getting. It is like stiffness of the beam. EI will be how much it can resist the deformation. When coming to Z, it will tell you how much maximum bending moment I can apply on the beam. So that beam will be in stepper.
It's the same meaning. So whether you just hold your ear this way or that way, it is in the same meaning.
Sir,
how much resistance you are getting? That's what they are telling.
EI is telling about deformation, sir.
What kind of deformation?
Like deflection. How much it will deflect.
No, Z is also telling you the deflection. What else? That means deformation for bending, resistance for bending, right? Both are telling the same thing, resistance for bending.
Sure. But Z will decide magnitude of the load that we can, moment that we can apply on the beam. When coming to EI tells about deflection, sir. Means actually in engineering design we don't need much deformation, much deflection the beam.
So how will you come to know? How will you come to know about the deflection from this?
How?
Okay. Okay.
Sir,
Anyway, Naveen.
sir,
Okay.
sir,
Okay. So. Okay.
1 minute.
mm,
Sir, we have a bending equation like m by I is equal to E by R.
mhm.
From that equation, uh, uh, m is equal to EI by R. If EI property is increasing for a given bending moment, if I increase the property of EI, then radius of curvature also increases. When radius of curvature is increasing, means uh, it
Okay.
is
Okay.
saying
Let me say this way. You are saying for a given radius of curvature, if I have EI is more, moment of resistance will be more.
to make into that radius, we need more bending moments.
Okay. My statement is to bend the beam into a given radius of curvature.
Uh,
If EI is more,
uh,
resistance
bending
for
mo-
bending will be more.
more bending moment is required to deform the
That's
body.
what that is the meaning of more bending. What that is
Uh,
more bending resistance will be. So same is even given by Z also. Z says the same thing.
Sir, here we are talking about bending. How much
No,
radius we are bending means deflection we are talking about here.
mm-hmm. Okay, so I will interpret it same way. For a given material, if you have that is sigma is constant,
Sigma for a material, sigma will be constant.
sigma is constant. If section modulus is more, then section modulus is more, then the moment of resistance will be more.
Then the failure moment will be more. Sir.
No, moment
Means,
of resistance. That means it is meaning is same. Moment of resistance that you're going to get because I have made sigma as constant.
sir, here we are talking about bending means to this radius I am bending. That radius will decide how much deflection at each point. Here we are
Okay.
talking about the
Okay. Do you
strength
know
of
about strain hardening?
strain hardening. Yes.
What is strain hardening?
Sir, when we are deforming one body uh, because of intermolecular activity, the yield strength of the material increases.
But yield strength is the material property. How it can increase?
So because of strain hardening, it is increased.
No. So what is the material property? Yield
Uh,
strength is yield strength material property or not? First question is this.
yes, sir, it is
If
material.
it is a material property, can it vary, change?
Sir, it can be changed, sir. By heat treatment and strain hardening, we can change.
We can
Means
change it.
by alloy, we are
But
doing something on
material is same. We are not hitting it. We are not hitting or we are not by hitting reducing its strength.
but we are straining it, sir. Because of
So
that straining inside, because of dislocations,
can you explain me with that how this value is changing? How why yield strength is increasing?
sir, on graph I can.
Yes, go ahead, please. Mm-hmm. Okay.
Sir, this is a simple session. From here I am loading,
Mm-hmm.
and this is strain hardening region from here to here.
Mm-hmm.
Now from here I am unloaded. When I load again, uh, now the material will start from here, sir, loading. Initially this is the sigma y. Now this is the sigma y. This is a graphical, but because of intermolecular thing, the sigma y of the material change increases.
Okay, Naveen. So now over to Vishal sir. So we'll give you the feedback at the end. Okay.
Okay, sir.
Yes, sir. Thank you. Yes, hello, Naveen.
Good evening, sir.
Good evening. So, Naveen, you are going for ECIL.
Yes, sir. Electronics Corporation of India Limited.
Yes. So, on 29th, you are having your interview.
Yes, sir.
So, let me ask you some question from heat transfer. I think you mentioned heat transfer, thermo, and SOM as your favorite subject.
Yes, sir.
So, Naveen, suppose if you take a rod, some kind of metal rod, which is hot one. Okay. Suppose you heated it by putting in a furnace. and suppose that road we are immersing in a water vertically. Okay. So can you tell me how the at that time of instant, like when you are dropping that road into the water, what kind of boundary layer formation will be there? Can you draw the boundary layer formation?
Yes, sir.
Mm-hmm.
Sir, I will consider that water is not vaporizing.
Mm-hmm.
Like the temperature is less than 100 degrees.
Mm-hmm. Mm-hmm.
Sir, sir, I think this kind of science is from bottom phase some heat is coming, so the fluid is getting heated up, and this fluid will go like this from this side.
What about the temperature profile?
Sir, fluid temperature is less,
Mm-hmm.
surface temperature is less.
And what about velocity profile? Just draw the velocity profile also on the right side.
So this is a pre-convection, so velocity will be very less, but still fluid flow motion will be there.
So at surface velocity is 0,
Uh,
and at the
yes, sir.
boundary layer
Surface.
and the fluid is having some velocity, but fluid is stagnant one. Outside the boundary layer, there will be no motion.
Sorry, sir.
Mhm.
I made a mistake. Sorry. This is how it is.
So fluid particle, they are going to move in the downward direction or upward direction?
The fluid particle will move in upward direction.
Upward direction.
Oh.
So where you need to show the velocity profile?
Yes, sir. Mirror, upside.
Upside. So it will be maximum at the center, means at the center boundary, or close to the surface.
Close to the water side, sir.
Close to the water side.
Because this side water is getting heated
So
up.
suppose
So because of
at that time of instant, in the beginning only, suppose we are interested to find out the H value, convection heat transfer coefficient in case of natural convection. So how you are going to find out that H value?
starting, sir.
Mm-hmm. Mm-hmm.
Not yet.
You heard about Rayleigh number. What is the significance of Rayleigh number in free convection?
Sir, a Rayleigh number will be mathematically it is equal to GR multiplied by PR.
Yes, very good.
Actually, GR is giving only importance to this buoyancy force and viscous force. So we need importance to thermal alpha, thermal diffusivity also. So we are multiplying GR with PR so that thermal diffusivity will be. We are giving importance to thermal diffusivity and the boundary.
No, fine, fine. What is the significance of that Rayleigh number in free convection? Okay. Comfortable, Naveen?
Yes, sir.
Fine, fine. So, Naveen, you did some training in a nuclear power plant. Sorry, thermal power station.
Thermal power.
So what are your major learning while when you have undergone that particular training? What you learned through that training?
Sir, the one thing which I'm there learned is that sir, in previously everything is manual, sir. Uh, every control is from manual, but nowadays everything is completely automated, sir. It is everything around control systems, sir. Control systems and everything. How much air to flow, how much coal to flow, how much of oil to be burned, uh, like mass flow rate of water, everything is automated. Everything is under the control of the systems. And whenever there is some need of human, then those people will work. But continuously under monitoring, everything will be there. Something appears to be abnormal, then they will act about it.
What are supercritical power plants, Naveen?
Sir, actually, there are two types of power plants, sir, subcritical and supercritical. Sir, when coming to supercritical, sir, water, there is no need of water pump, sir. Directly, the water will be converted into steam, and that steam will be passed to the superheater, and from there, direct utilization. But in subcritical, we will heat again, water and steam will be separated. Again, water will be circulated to get converted into steam like that.
What are the
So we get
advantages when we are using a supercritical power plant? Supercritical Rankine
sir,
cycle, you can say.
in terms of efficiency, we will get high efficiency from supercritical power plant. 1-2% more we are getting compared to subcritical power plant. That's the reason why we have.
So how much is the critical point for water?
Sir, for around 250 bar, some number will be there, 250 bars, around that.
50 bar is a critical pressure. How much is critical temperature?
370 degrees centigrade. Values not remembered, but
Okay, okay. So can you recall any supercritical boiler?
sir, yes, sir. Benson
There are so many
boiler.
boilers.
Yes, sir. Benson boiler is a supercritical boiler.
Benson boiler is okay. So how it is different from a high pressure boiler?
Sir, supercritical boilers are high pressure boilers.
Mhm. Supercritical, no, but if you go to the categorization, high pressure, they are having pressure range in the range of 180, 80 to 180. Supercritical, you are having pressure even more than 221 atmospheric. Okay. Naveen, can you tell me the difference between a peak load and base load power plant? And what do you feel? Thermal power plant is a peak load or base load power plant, and why?
Peak load and,
Mhm. Any idea about thermal power plant is a peak load plant or base load plant?
the meaning of peak load and base load, I'm not getting.
Okay, you are not aware about that peak or base.
Peak.
Okay. What is okay? Fine. Okay. So what is regeneration in Rankine cycle, Naveen? What are the advantages of carrying out regeneration?
Sir, I will draw a graph and then I will explain.
Yes. Take your time.
Sir, the main advantage of regeneration is in boiler we are supplying heat, sir. The heat from steam we are supplying to the water, so that whatever heat we are supplying in the boiler will be at higher temperatures. So that whenever heat addition at a mean temperature increases, efficiency of the plant increases. So we are heating the water to saturation temperature of the water by using steam. From there, we are converting that water into steam by using heat from the boiler. So that mean temperature of heat addition will be increasing, so that efficiency increases.
Naveen, what is second law of thermodynamics?
Sir, the limitation of first law is direction of energy flow. It won't say. Second law says that heat always naturally heat flows from high temperature to low temperatures.
What is
There are
irreversibility?
two statements.
Yes, sir. What is irreversibility? What do you understand by irreversibility?
Sir, actually, sir, when coming to reversibility, whenever some process is going on, if the process can go back by the same path to the initial condition, we call this as reversibilities. When coming to irreversibility, when same state means a system is going a process and it is we are trying to get back the system to back to the initial position, but still it won't come, sir. Those kind of processes we say reversible, means the effect of the system will be somewhere in the universe.
Okay, Naveen, my last question is to you. Naveen, can you tell us the working of a microwave oven, or how the microwave heating is different from conventional heating?
Yes, sir. Sir, uh, in convection, uh, convection is one type of heat transfer process. When coming to microwave, there we will use the concept of radiation because of electromagnetic, the energy carried by the electromagnetic waves in oven, the matter gets heated up, sir. Food material. When coming to convection, we need one heat source and we need a fluid to carry that heat to somewhere. Here there is no need of medium. Those energy particles will directly enter into the food. Both are two different phenomena of heat transfer, convection and radiation.
Okay. What is Weng's displacement law? You heard about Weng's displacement law? What is that?
Sir, sir, actually, sir, every body which is having temperature greater than 0 Kelvin emits a radiation, sir. Wein's displacement law says that body emits radiation at a different wavelength, sir. A body which is having higher, it gives a relationship between wavelength of heat radiation and the temperature of the body. The multiplication of wavelength of the wavelength where maximum amount of radiation taking place and the temperature multiplication of those two will be constant, sir. Means a body at a higher temperature will emit the radiation at a lesser wavelength. It emits the radiation at a lesser wavelength.
Okay, Naveen. I think now we can provide you the feedback.
Okay.
So, Naveen, I asked you some question initially from the heat transfer that you answered, the boundary layer formation, velocity profile, temperature profile. No, in free convection, the Nusselt number is a function of Grashof and Prandtl number. So what you need to say case of initially, because it's a case of road, vertical road, which is immersed in a water. So clearly it is a case of free convection. Otherwise, you can check through Richardson number whether it is less than 1 or greater than 1. Okay, so you will be able to show yes. Obviously, when you are immersing in water, there is a case of free convection. There is no need to check. But in general, if you want to check, you can check that number just to check whether the forced convection is dominating or free convection is dominating. After that, you need to check like at the end of the road, the flow is laminar or turbulent. So easily you can check by Rayleigh number. So Rayleigh number gives us the nature of the fluid flow in case of free convection. Reynolds number gives us the nature of fluid flow, whether the flow is laminar or turbulent in case of forced convection. In free convection, that nature we are going to get through Rayleigh number. If it is less than 10^9, flow will be laminar in case of vertical road plate, and otherwise if it is more than that, flow will be turbulent. So you need to check the Rayleigh number. And then after checking the flow, whether it is laminar or turbulent, easily you can use some of the correlation between what Nusselt number and the product of Grashof and Pendant number to find out the H value.
Yes, sir.
For the idea, I mean,
Sir.
so because you have not answered that, then that's why I have not asked you other questions like how it is going to cool. Actually, it is a case of unsteady state heat transfer when you're immersing road in water. So interviewer can ask you some question related to the Biot number. What will be the temperature profile? Okay, what is Biot number? How the temperature of the road is going to change with time? These kind of things. Power plant, because you did some training and you are mentioning that training in your introduction part. So then there are high chances, because whenever you have undergone any kind of training and you are highlighting, so interviewer is going to ask you some question from that. So you need to prepare that. Different kind of power plants we are having: peak load, base load. Peak load are the plant which we actually run for a very small amount of time. They're not going to run for the entire day. They are only going to run for a very small duration when the load will be maximum, as the name itself is describing, peak load. So peak load power plant will be something like that. They will be easily able to start and easily able to shut down. उनका starting time, shutdown time बहुत कम होता है, like gas turbine power plant, diesel power plant, okay, compressed air power plant. So these kind of power plants are what peak load power plant. Base load power plants are what, which are much more economical. The power generation cost is very low, okay, but they are, their economy is required to be very high because they are going to run entire day. So a load which is always there on the plant, that is known as base load. The load which will be there on the plant for a very small duration, that is known as peak load. So thermal power station, nuclear power station, these are base load plant. Why? Because they are going to run the entire day. You cannot shut down a thermal power plant, suppose if the load is decreasing. You cannot do that because they are going to take much time. Even if you are starting a plant and you are shut down a time, they are going to take a day actually. Okay, is that fine? I mean, regenerative Rankine cycle advantages that you answered. That was fine. I asked you about second law, but very brief actually you mentioned about second law. There are so many things you can mention about second law of thermodynamics. Irreversibility, what you going to say? Okay, sir, irreversibility is nothing but the loss of work potential. In any real work, sir, actually we lose work potential. Energy is conserved, the energy is going to remain constant, but what we lose the quality of energy. There must be degradation in the quality of energy. There must be loss of work in any real process due to what? Irreversibility. Then you can highlight what are the reasons behind irreversibility: internal irreversibility, external irreversibility. Second law, you can highlight about the importance of the direction of a process, in which direction process is going to execute. PMM2 concept you can highlight. 100% efficiency impossible, PMM2 impossible. So all those things you can highlight. Overall, it's looking fine. थोड़ा सा energy बढ़ाना है आपको भी. Slightly in energy you need to improve so that it will look like yes you really want that job. ठीक है, अभी थोड़ा average है, interest इतना ज़्यादा नहीं लग रहा है. Remaining technical is looking fine. You are trying and you are answering in the right direction. But थोड़ा बहुत और exposure चाहिए. You are having less time, 7-8 days. So at least work strongly on these three areas, like heat transfer. Thoroughly study entire subject. Marathon class is available 7-8 hours. You can watch that marathon class. Okay, that will help you a lot. Thermodynamics marathon class, watch. Okay, that is also available by Dr. Vijender sir. And yes, then some basics about power plant if you'll explore, that will be sufficient. Okay, and yes, some other parts home you need to cover. So these three subjects are more important. And improve your energy and go for another mock. Okay, do these changes and we'll again we'll discuss further what you need to improve. Okay, Naveen? Okay, good luck.
Okay, Naveen. See, they already know that you may be getting calls from other PSUs also, right?
Yes, sir.
So first part is
Sir,
that
actually, why I am actually going by Israel is the posting will be in Hyderabad. I am from Andhra Pradesh. That is the major reason why I am rejecting. Even if I am selected in IOCL ONGC, I won't go, sir. I will stay in Israel, sir, because of location.
no, sorry. Can you repeat one more time?
Sir, actually, Israel location is from Hyderabad, sir. I am from Andhra Pradesh. Even if I got posted in even if I got selected in IOCL and ONGC, still I will stay in ECIL.
No, so they have their office in Hyderabad only.
Hyderabad. Yes, sir. Head office is in Hyderabad. Very small, small branches in outside, sir. Kolkata, Delhi. Very small. Posting is 100% will be in, but officially I can't 100% I can't say, but posting will be in Hyderabad.
Mm. Okay. So then I think you can mention a little bit. You can just tell it as your priority. For example, you can say that, okay, sir, in terms of PSUs, overall, all the PSUs are equally good in terms of facilities and all that. So the areas why I will prefer ECIL would be, one is that you mentioned about it, they're focusing on newer technologies, right?
Yes, sir.
So just so if you have the idea, just go through the website and check out what are the areas in which they are working and where, as a mechanical engineer, you're gonna have a contribution. So if you think that, okay, there are many areas in new areas where you can work, you can get the opportunity, then you can mention that, no issue. That is a positive point that way. Whereas in other PSUs, maybe you may not get the chance that easily or something. You cannot say that, okay, many PSUs are focusing on same thing. Don't say that way, but you say that I have gone through the profile of ECR and all that. So I find that there are many areas where I can contribute a lot and newer areas where I can focus. One more thing I have found is that, okay, there is hype if there is a little probability that I may be posted in Hyderabad, even though I know that there are other offices also. So in addition to it, this is also one of the areas I think that will be to my advantage since I belong to the place nearby. So that way you can mention it. Okay.
Yes.
So that is how you have to mention it. And internship, because you have done internship in NTPC. So definitely they are going to ask the questions related to your power plant also. They can ask questions from that area also. And you have done the project which you are talking about the coating, but better you focus. Just try to find out the applications where this particular Electrolux coating methodology is being used presently, and then you just tell that, okay, it was a kind of experimental project where we wanted to find out that by varying the thickness of these different materials like aluminum oxide or silicon carbide, we wanted to test that how much change in hardness and surface hardness takes place and all that. So you can tell that will be better, I think, because when you will tell that way that, okay, it was an experimental investigation, then obviously then they are going to ask, okay, what were the results, what was the base material, how much was thickness of the coating you carried out and all that. If you have done it experimentally, then those results they will definitely ask you to share, and what was the end result, right? But just get the idea of applications, what are the different applications where it is already being used and why you chose that particular project, right? Which PSU? I think there you got didn't get the very clear, but okay. At the later part, you said that, okay, focusing on newer technology, but don't say anything about other PSUs. Hmm. You mentioned about 50%. I don't know what was that. 50% of something is something. I don't know what was that. Anyway, and
This center,
okay, yes.
this center,
For
this selection.
Okay. And what are the favorite subjects that you are telling, for example? So they are going to ask the question from there. They're going to get that check whether you are having deep understanding on that or not. NTPC power plant, I think you should prepare because you have the internship. They are going to ask the questions from there. SOM overall it seems okay, but see EI and Z, see both of them are trying to give the same kind of indication, resistance for deformation in bending, right? So one is material property, another one is geometric property entirely. Z is entirely geometric property.
Yes,
How that a particular geometric section will respond if it is placed in a certain way, right, for bending resistance. Whereas when you are talking about the EI, E is the material property. I is the geometric property. So combination of geometric and material property, right? If I will change the material, E will change. I can increase the bending resistance if I take a material of higher modulus of elasticity.
Sir,
Right?
But strength of the beam is equal to multiplication of sigma and Z, sir.
That is okay. That way you can talk. But if I say that, okay, what do they indicate? You will say they both of them represent the resistance only. That is, one is talking in terms of maximum resistance. For example, you are saying that, okay, if I take it as an allowable value, sigma is allowable, then Z section modulus, if I take, so this will become the maximum the resistance that particular section can offer, right? Whereas in case of EI, it is simply telling the resistance. But both are telling about the resistance, right? Both are telling about the resistance. So one is that you must differentiate in terms of the kind of property it is. For example, one is geometric. It is simply telling about the geometric section only. But the other one is giving the indication in terms of if I change the material also, so then it will tell you the particular. And strain hardening, even you explained it well. But in terms of this strain hardening, why the strain hardening takes place? So it should be dislocation should come into picture. It is because of dislocations, and dislocations play important role. So that term should come out over there clearly, and how the dislocation basically lead to that increase in strength, right? So otherwise, the SOM seems to be okay. Like you are having a little that is understanding. But okay, just go through different mocks and just revise that whole of that topic again. So it will be better, I think. You can catch up with this particular topic, this particular subject, I think, in this period of time. So I think you still have time. So go ahead with the revise the subjects properly and just see the areas where they are working and where you want to align yourself, I think, and then it's fine. Okay?
Okay. Okay.
Okay. Okay, Ravit. Good night.
Thank you, sir.